and the outputs differ when you use the same dataset for both kernel density and point density. In ArcGIS Pro, if you choose one tool over the other, without understanding their statistical differences, you may misinterpret the spatial patterns in your data. In this video, we'll explore the structural differences between kernel density and point density. These differences directly affect the shape of the density surface, the identification of hotspots, and the interpretation of your final map. We're going beyond simply running the tools. We'll examine what each method actually measures, when you should use each one, and which method better represents the spatial reality of your problem. Join me. What each method accurate, more informed, and more professional analytical decisions. In raster analyses, such as kernel density and IDW, adjusting the environment settings before starting the work is essential. This step prevents inconsistencies in the coordinate system, pixel size, analysis extent, and cell alignment. Snap raster in the output layers. Now, move to the Analysis tab, and in the Geoprocessing group, click on the Environments button. In the Workspace section, set both the current workspace and the Scratch workspace to the Exercise 23 Geodatabase, located in your Exercise 23 folder. While you could set the Scratch workspace to a different path, for this tutorial, we will keep both set to the same exercise folder. Next, in the Output Coordinates section, set the Output Coordinate System to match the coordinate system of the depth addresses layer. Which is WGS 1984 UTM Zone 30 North. Moving to Processing Extent. Set the extent to the boundaries of the study area layer, ensuring the processing is confined strictly to that area. At this stage, you do not need to adjust the snap raster. Finally, in the raster analysis section, set the cell size to 3, meaning each output raster cell will be 3 meters. Then, for the mask option, select the study area layer. So that all calculations are performed only within that defined region. Once you are done, click OK to apply and save these environment settings. Let's create a kernel density surface. Go to the main ribbon, click on the Analysis tab, and then select the Tools button. In the search pane, type and open the kernel density tool. For the input point or polyline features, select the depth addresses layer. In the population field, choose the number cases field, which represents the number of cholera incidents at each location. For the output raster, name it cholera_KD. This will automatically save into the geodatabase we configured in our environment settings. The output cell size should already be set to 3, meaning each output cell will be 3 meters by 3 meters. Next, set the search radius to 200 for a 200-meter search distance. Ensure the remaining settings are as follows. These are usually the defaults. Area units should be square kilometers. Output cell values set to densities. And the method should be set to planar. Finally, click Run. Once the processing is complete, the cholera_KD raster will be added to your map automatically. Map interpretation. This map displays the density of cholera cases in Broad Street, London, in 1854. Red points, each point represents a cholera case. Colored areas indicate the density of these cases. Dark purple indicates the highest density, the highest number of cases in a small area. Lighter colors indicate lower density. This map helped Jon Snow understand that the cholera outbreak was centered around a specific water pump, likely the Broad Street pump, identifying it as the source of water contamination. This study is considered one of the cornerstones of modern epidemiology. To compare performance and structural differences in visualizing the spatial distribution of phenomena, a similar analysis can be performed using the point density tool. While the kernel density tool uses a bell-shaped mathematical function, a tapered kernel, to create a smooth density distribution based on distance, the point density tool calculates density in a simple manner by dividing the total number of points within a neighborhood by the area of that neighborhood. Performing point density analysis. First, open the tool. Navigate to the Analysis tab, click Tools, and search for the Point Density tool. Next, set the input point features. Select the def_addresses layer from your list. For the population field, choose number_cases, dot. Now name your output. Enter cholera_ for the output raster layer. Set the output cell size to 3. Please ensure this matches your current environment settings. Under neighborhood settings, select circle as the shape. Finally, set the search radius to 200, and you are ready to run the tool. For a visual and precise comparison of the results, you can use the swipe tool. This powerful tool allows you to dynamically compare two spatial layers that are stacked on top of each other. By creating a movable divider line, swipe pushes aside part of the top layer to clearly reveal the differences in the layer beneath it. For example, the smoothness of the kernel density output compared to the blocky appearance of the point density result. How to do it? In the Contents pane, click on the top layer so that the Raster Layer tab appears in the ribbon. Then from the Map tab, select the Swipe tool. Now, by moving the mouse pointer across the map, you can compare the two layers side by side. Comparison of the two methods. Both tools answer the same question: where does the event occur more? However, if you want to understand how the intensity of the event is distributed across space, kernel density is the more professional choice. That's because, in kernel density, each point spreads its effect into the surrounding area using a tapered kernel function, creating a smooth, continuous surface. Point density, in contrast, simply divides the points into fixed, blocky neighborhoods and calculates the number of points or the sum of weights per unit area, which usually results in a stepped, block-like output. If you found this tutorial helpful for your GIS projects, please don't forget to like this video and subscribe to the channel for more spatial analysis tutorials.
thank you for joining me throughout this tutorial. If you found it helpful, please give it a like. If you're not subscribed yet, hit subscribe so you don't miss the upcoming parts of our GIS analyses. And feel free to leave your questions or suggestions in the comments.